Hi everybody, this is Mrs. Ellsworth, and what we're going to be talking about today is the second lesson in rational numbers. And so let's go ahead and take a look at this. You should already recognize part of this diagram that the natural numbers are the numbers that you count. Well, you start counting. So they're also called counting numbers. 1, 2, 3, 4, 5, 6, all the way up to infinity, right? Whole numbers are natural numbers plus you're adding a 0 to it. So whole numbers start with 0, and they're all those positive numbers all the way up to integer, all the way up to infinity. Now they do not include negatives, and they do not include fractions. Integers include negatives too. So that includes your 2 and your 8 and your 0, and then any negatives also. So they don't include any fractions, okay, but they include all of these. Rational numbers include all of this, right? And so rational numbers, your book wants you to recognize that rational numbers is like this right here is 2, and well, let me do it this way. If you go and you look at this, you've got the word ratio right there. Okay, you've got the word ratio. I don't know what happened to my marker there. You've got the word ratio in rational numbers, and so so we could go and look at this and recognize, does this have a ratio in it? Well, we just went and worked on that reference table that you're supposed to have for a bookmark, and so you should recognize that this is 2 1/3. Okay, and then your book also wants you to go further and do this as 7/3 by taking 2 times 3 is 6 plus 1 more, and you get 7/3, so that you can recognize that, hey, that fraction, which is really a ratio, okay, that is a rational number. Well, if you've got anything that's got a repeater bar over it for a decimal, or you've got anything that has got a terminating decimal, those are rational numbers. So you can just recognize them quickly. And you can see that this is a ratio, even though it is not just as a fraction right now. You'll know that it converts into 1. So those are some key things. So how do you know when it's not a rational number? Then it's irrational. And numbers like pi, that is 3.14159, blah, 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 that keeps on going on forever. And it has no pattern, and it has no repetition in it. And so that one is an irrational number. Now this one's got a pattern in it, 0.191191119, and it's going to keep on going, let's say. Okay, and so this number right here, though, however, does not have anything that's got a repeater bar over it. It doesn't. Nothing repeats over and over and over. So it will be an irrational number. Also numbers like, well, like the square root of 3. That's also got a number that doesn't have any kind of pattern in it at all, nor a repeater. But the key to this one is that you can't use a repeater bar over anything. Okay? You can't do that with an irrational. You can with a rational number. Okay, so let's go and look at this, and I hope that you recognize that this right here is a mixed number, and they want this as a fraction. So when you have this in your assignment, it says write each rational number as a fraction. They want it to be written as a fraction, not an improper mixed number. Anyway, so this right here we would go take 6 times 6 is 36 plus 1 more. So if you can't remember what you did because you got some brain fog going on there, go and write yourself some notes. 6 times 6 plus 1 more is 37. On this one, what do you do when you got a whole number like that, or an integer I should say? Just go put it over 1, and that is your answer. Okay, so this right here is example number 1. And so when you've got other problems in your book and that asks you to refer to example number 1, that's great. Okay, how do I do this? I'm going to forget that this has got a negative answer in it, so I'm going to go and circle my negative in there, or else I will screw up. So we've got 4 times 8 is 32, plus 3 more is going to be 35. So it's a negative 35 on top, and then you still keep the same exact denominator that you had before, and so that will take care of that. So we got negative 35. Oh, forget the answer there. Sorry. Anyways, this right here is 10, so you just go put 10 over 1 because they want a fraction. That's what the instructions say. So how would you go and put this in the computer for your problems? You would just go write negative and then 35 and then the divisor bar they've got a slash for it, and is down by the question mark on your keypad, and 8. So 35/8, and that would be negative. Don't forget that negative in front. That would. Okay, so let's go ahead and look at this one. This one is, I want you to recognize that 64/100ths. You'd write that as 64/100ths, but there's also another little thing here too. You can recognize that it's 64, okay, that's your numerator, 64, and then how many digits is in 64? 2, so I got a 1 and then 1, 2, 2 zeros. 2 numbers, 2 zeros. And so you might be able to recognize that, hey, that this number is divisible by, because you got to simplify these. It says write the fraction as the simplest form. So you've got to simplify it, and when you do that, you probably recognize it's divisible by 4, but if you didn't, you saw that there were 2 even numbers back here, so you could go and divide it by 2. Okay, if you divide it by 2, it's going to be 32 over 50. And then you'd notice, hey, this right here is even again, so I got to go and reduce it again. And that's going to be 16 plus 16 equals 32, so there you go. Okay. Next. Okay, so this is 9, and I should probably read this. A handheld video game system weighs 9.675 ounces, and write a decimal as a mixed number in the simplest form. So we can go ahead and go. And so 675, and then how many zeros am I going to have here? Well, 675 is 3 numbers, so I'm going to have 3 zeros. Okay, so I recognize that this right here is divisible by 25 because I think of money, quarters. Okay, and so, but do you recognize that like if it ended in a 5 or a 0, it could be divisible by 5? Okay, you could go ahead and reduce it a couple times if you didn't see it was 25. That's fine. And so the number to be divisible by 3, you'd have to add up your numbers. Like 42 is 4 plus 2. Well, let me write that down. We've got 4 plus 2 equals 6. 6 is divisible by 3. So that's the check that you always do to see if it's divisible by 3. Now, if you wanted to see if something was divisible by 6, it would have to be an even number because 6 is 3 times 2. So it would have to be even, and it have to be divisible by 3. Okay, so that's just one way that you could check that. Okay, so let's go ahead and continue with this number up here. And so notice that I'm going to go, and I know already because I was setting up this problem, that 675 is 27 times 25. So I'm going to go and divide it by 25, and I get 27 on the top. And I'm going to divide the 1,000 by 25 also, and I'm going to get 40. Okay, so now this is where I would goof up. So watch out, beware, beware, beware. Don't forget that this answer here's got to have that 9 in it, and is 27/40. Okay, so beware, beware. Maybe you could even go and write this circle with a 9 right away before you even reduce that so you don't forget, because it is easy to do. Okay, so in your notes or in your practice problems that you have, when it says write each number as a fraction, so you would go and make these top heavy. Okay, and don't forget that negative there. So like for this one right here, I'm worried that some of us, because I've done this myself, will forget that our answer has to have a -1. Oops, that's supposed to be a negative. Okay, and then 3/4 is 3/4, so it's $0.75, right? Okay, I was just thinking quarters there, 3/4, 75 cents. Okay, so look at those, and you know these ones are here. They don't fit in that category that you used for your reference things on fractions and converting. Anyway, so I got a trick for that. Your book has got this craziness going on here. They'll tell you to, I've got a trick for it. They'll tell you to go and, well, let me give you my trick first. How about that? Oopsie. Okay, so like let's take number 24 here. 24 has got 36/100ths, but it repeats, and that's a problem. So you've got 36, Okay, and then how many things repeat? There's 2 of them that repeat here. So I'm going to go and put that over 2 9s. And then I just reduce it. Okay, so I know that this is divisible by 9, so that's going to be 4. And this one is divisible by 9, so that's going to be 11. 9 divided by 9 is 11. And that's going to be my answer, 4 11ths. Now, let me erase that here and show you what I mean, that the way that the book does it is quite hard. Okay, so looking here, this is what the book does. It tells you, so here's your number, and they want you to write as a fraction the simplest form like we just did with 0.36, but they tell you to do it this way, okay, and then you go and you figure out, well, times each side by 10, and so you get 6.6666, and then you go and you subtract a negative end. Well, just go and divide it by the number of 9s. You have one number that repeats here over and over, so you take that number and divide it by 9, and then you reduce it, and it happens correctly every time. That's just kind of a trick of the trade. And you in your reference sheet right here, you could even go and write yourself a note. If it's a repeater, put it over some 9s, and how would you tell yourself more stuff about that? So write yourself notes that's good for your thinking, okay? Okay, so write this fraction in simplest form. We're going to go ahead and move ahead to the 4th type of problem. And this is asking you to identify these. Okay, so you don't need to do any kind of conversions. Unless you really think you need to, then you can. Notice that this right here wants you to tell you which type of number set it is. Well, I know that this one's a ratio. Okay, I can go and make this into a top-heavy one. That's fine, but you don't need to. It's a ratio, so it's a rational number. Okay, so it's a rational number. There we go. This right here is just like that other example that I had. It doesn't have anything that you could have a nice repeater bar over like this one. So that makes this one a rational number, but this one will be nothing of like that. It'll be an irrational number because it doesn't have a nice pattern that you can put a repeater bar over. And 45 could be any of these, couldn't it? It could be any of those. So what I want you to do is not the biggest one. So like this right here is a rational number. It didn't fit any of these other categories. So what is the smallest category that you can get this down into? That's how we will do this instead of writing out all these answers. It's a natural number, whole number, and an integer. Instead, I would like you to have your answer just be the smallest one that you can get down to, which is a natural number. Okay? Yeah, I think that's how I want you to do that. Okay, so if you had like a negative 45 here, then your answer would not be a whole number. It would not be a natural number. It would be integer. Yes, I realize it could be integer or a rational number, but we're going to have what is the smallest one you can get it down to. That's what we'll do. So in your note, in your assignment, you can recognize that to identify these, if they've got that crazy pattern, what kind is that? That is going to be that irrational number. And hey, right there's a counting number, so that's going to be a natural number. Boy, I just had a... Okay, so I think that is it. Yep, that's it. So I will see you when I see you. Bye-bye.